in 8.4, there's nothing really new. All that we're doing in 8.4 that is different than what we did in 8.1 and 8.2 and 8.3 is that we're going to do two things together. We might rotate, then do a reflection. We might do a reflection, then translate it. We might translate it, then do a reflection. So we might add two of the things that we've done before in coordinate notation. So the first thing I want you to know is that the way that this worksheet works is it splits things up. It splits up moves by using the word then. The word then, and I'm going to put a box around it so you know that I'm not actually writing a sentence with the word then. The word then is going to separate it, separate your moves by the word then. The word then separates the transformations. Then is your key word. It's what separates your transformations. There are three types of transformations. There's the translations, the reflections, and the rotations. When you see the word then, keep that in mind. So let's go ahead and do an example, and hopefully everything will make sense, okay? I'm going to do an example like number 3 from this worksheet. Number 3 says, translate left 6 and up 4. Then rotate 180 degrees counterclockwise about the origin. That didn't look very focused. Let's try that again. There we go. Translate left 6 and up 4, then rotate 180 degrees counterclockwise about the origin. What your worksheet looks like, if you haven't seen it yet, it has all your xy's, then it has an arrow, and then there's a gigantic blank spot like this, and then it has something for your x and your y that you have to fill in, and then it has another arrow, and it has another spot for you to do a second transformation. So what I want you to know when you're doing these kind of problems, remember how I talked to you about the word then? It separates the transformations. Let me highlight that word then right here. I'm going to highlight it in yellow. What that means is you have to write your first transformation. Here's your first transformation. And here's your second transformation. Your first transformation here is what you're going to fill in on the left side, on the very first set of parentheses. It's kind of hard to see, but it says translate left 6 and up 4. When something goes left 6, does that affect your x or your y?
X.
If it affects my x, do I add 6 or I subtract 6?
Subtract 6.
So my first answer here is going to be x minus 6. Because it goes left 6, I subtract 6 from my x. Then it says up 4. Does that affect your x or your y?
Y plus 4.
And do I add 4 or subtract 4? Y plus 4. What this means is we're taking all of our xy's, we're moving our x's to the left 6 and our y's up 4. If there's a 3-sided shape, it moves all 3 sides. If it's 4-sided shape, it moves all 4 sides. And so on. Good job. Now what we have to do is we have to rotate 180 degrees counterclockwise about the origin. I want to give you a little picture of what that looks like. Okay, I'm just going to draw something right here. Let's pretend I had an object, and this object, I'm going to represent A, right? I'm going to put A right here, underneath here, okay? I'm going to call this point A. Here's point A right now, point A. Boom. Right there. We don't know where it is. It's just out there somewhere. It's been transformed, so let's call that A prime, as a matter of fact. Let's add a little prime there. And now what we're going to do is we're going to rotate 180 degrees counterclockwise about the origin. Let's say you're using your patty paper and you were to rotate it 180. This is what it would look like. 90. That didn't really rotate very smoothly. 180. Agreed? Right here, I'm going to put A double prime. What this shows you is that whatever your x is, let's say I'm out here. If my x is negative, when I come over here, what happens to your x coordinate? Your x changes signs. It becomes a positive. It's the opposite of. Now what about my y? Let's say this is my y. What happens with my y when I go 180 around or about the origin? Does the y become? Negative. So I need to change the x. The x needs to become the opposite sign, and I need to change the y. So from A prime to A double prime, I need to do the opposite sign of x minus 6. Here's what that looks like. Instead of x minus 6, I need to do the opposite of x minus 6. Opposite of x minus 6. Do you know how to do the opposite of x and the opposite of negative 6? Do you know how to distribute that negative? So let's simplify it, please. Let's simplify it. What is negative x, negative, and the negative negative 6? Let's distribute this negative sign. What does that become?
Plus 6.
Okay, this is what I want your final answer to look like. This is how a scholar would write it. They would simplify it for the person grading their test. Now what we did is we changed the sign for our x coordinate. We also have to change the sign for our y coordinate. If you saw how I did this one, the x coordinate, you should know how to do the y coordinate. And then don't forget to simplify it. So instead of us doing y plus 4, I want the opposite of that. If you need a step by step, it's the opposite of, in parentheses, y plus 4. Do you know what that simplifies to? What's it going to simplify to? Say it out loud. If you said negative y minus 4, you are correct. Perfect. That's what I want. It's a little difficult. Why? Because you have to think in terms of any point. If you struggle, like sometimes it's hard for me to visualize it. It's hard for me to do it in my head. What I did was I just picked any point and then I rotated it. You can draw any point in any quadrant and then follow the rules, and you should be able to come up with the rule. This is what helped me. And it would have helped me if I would have did it in this quadrant or this quadrant or this quadrant. It doesn't matter. It follows the same pattern. Okay, I'm going to do one more example, and then I'll highlight one more thing, and then we'll be done with these notes. Let's do one more, like number 6. Says reflect. I'm going to move this up just a bit. Reflect over the x-axis. Then translate up 1, and left 6 units. Then they have x comma y, an arrow transforms to, and then they got this blank for you to fill in. Then they have another transformation with some blanks, with a comma, and there we go. Reflect over the x-axis, then translate up 1 and left 6 units. So the first thing that I do is I put a box around the then. I have two things to do here. I have the left side to do, and I have the right side to do. The second thing I kind of do is I go, okay, well, I got to do what's over here first. I have to reflect over the x-axis, and that's this pink part. Then what I got to do with that is take it and do it for the yellow part over here. Okay, that's kind of like two pieces to it. If I don't know what to do, what I'm going to do is draw a generic point. I'm going to write this. Draw a generic point. This is kind of if I get stuck. So my generic point is I pick a point somewhere, and it doesn't matter where you put it. I draw a generic, here is A. A generic point. It could be in quadrant 1. It could be in quadrant 2. It could be in quadrant 3 or quadrant 4. It doesn't matter. I have a generic point. Here's an A right there. Bang. I need to reflect it over the x-axis. So when I think of this A, it's some x and some y. Okay, I'm just going to put an xy next to it. It's like over here. Pretend it's a number. Pretend it's like 2, 3 or something. And I need to reflect it over the x-axis. Do you know which one the x-axis is? Is it horizontal or vertical?
Horizontal.
Those of you who said horizontal, you are correct. There's my x-axis. That means that this A value has to bounce or go over this pink line and shows up down here. This is where A prime is going to be, right? What changes from this xy? If it was 2, 3, what's this point going to be at?
-2,
Oh, still the same x though. Remember, this x stays the same. What's changing now? Yeah. So the x coordinate stays the same. How do I say that in mathematical words? X stays, x transforms to x. That means it stays the same. Your x's stay x's. My 2, 3, the 2 stay to 2. My x's stay x's. It transforms. Well, technically it doesn't. It stays an x. What about your y's? 3 went to -3. What does that mean? Your y transforms to what?
-1.
Perfect. You get that, then the rest of this worksheet's really simple. That's what we do. That's how our tests are. These are the questions that a lot of kids miss on the test. Okay? So if you get this, you're nails. Then translate it up 1, which means up 1. Does that affect your x or your y?
Y.
So wait, not just y plus 1. We have to take this y, the A prime, we have to move it, and we have to move it up 1. So this negative y becomes negative y plus 1. Does that make sense? And left 6. Does that affect your x or your y? And so, do I add 6 or subtract 6 from the x? And it's from this x. This x we haven't changed, so it's just x minus 6. Simple? The other things that are on this worksheet, you're going to have to describe transformations in words. I don't think that that's going to be too difficult. I'm going to show you what I'm talking about in case we need to see it. It's going to give you some directions on how to reflect a line. So you're going to see a review from 8.3. And then on the back side, it's going to ask you questions to describe the transformations needed to produce the images. Do not think that that means coordinate notation. It means write it in words. How do they go from here to there? And there are more than one answer. Some of you might think it's a rotation. If it does, your patty paper will be able to prove it. Sometimes you're going to have to reflect something. Let me kind of show you what I'm talking about. Here's my object. Sometimes you're going to have to reflect it over something. Did I reflect it over the y-axis? And then to make it match up, then I have to translate it down so many units. How many units? Down 3. So it's a double transformation. It is a reflection across the y-axis and then translation down by 3 units. You're going to describe that in words. And you'll look at these other shapes to say how the images were created. Let's stop our notes right there.